Hello, my name is Hector, and welcome to our webinar on MasterPlex ReaderFit. I will walk you through each step to successfully analyze your ELISA data. ReaderFit is a software designed for quantitative analysis, such for ELISAs, cytotoxicity studies, and other curve fitting assays. But before we dive into the software, a brief history of the company. The Mariah Bio Group of Hitachi Solutions Limited started and was established in 1999 and acquired by Hitachi Solutions America in 2006. With over 12 years of experience, it is the mission of Mariah Bio to provide trend-setting life science products and services to an ever-growing global population. To learn more of the company, please feel free to visit us at www.mariahbio.com. That again is www.mariabio.com. Okay, so from here, let's talk a little bit more about the software. Our agenda for today is show you how to download MasterPlex ReaderFit to add your data into the software, to fit your curves, and determine if you're doing dose response to determine IC50, EC50 values, and lastly to view your results and customize reports. So from here, we will go to the mariahbio.com page. You can download MasterPlex ReaderFit and a free trial from our website simply by looking for the ELISA analysis software and clicking on Curve Fitting Desktop. Here, a new window will appear and it will ask for your details to download a free trial. While we're on our website, I did want to mention that you can always contact us if you have any questions, either by phone or on any of our web pages by looking at the bottom right hand corner, the green, and clicking contact us. Right now we're not around, but feel free to give us a call or drop us a line when we are online. Okay, so after you have successfully downloaded and installed MasterPlex ReaderFit, go ahead and open it, and a blank plate should appear. So this is the first interface for MasterPlex ReaderFit. Today I'll be analyzing quantitative data to interpolate unknown protein values from a standard curve. However, if you're doing dose response analysis, I'll also show you how to retrieve IC50 and EC50 values, along with EC or IC anything. As you can see here, when you open MasterPlex ReaderFit, there is a useful ReaderFit user guide. We're going to go ahead and follow this so that you can also have all our points in text along with in audio. So first, I will go ahead and import my data. So a lot of your data looks like this in Excel. That's can be retrieved from any plate reader. In this data Excel sheet shows a 96 well plate, and to add my data, I'm simply just going to copy and paste it straight into MasterPlex ReaderFit. So I will copy, select the top left well, right click and select paste data. Within paste data, you have 4 options: to paste response values, independent values, sample names, and even group names. In this case, it's our response values from our plate reader. And our data is input now. From here, like I mentioned, we're going to follow the ReaderFit user guide. And in this case, I have successfully pasted my data. So we'll move on to the next step. Data analysis type. So like I mentioned before, I'm going to be doing a quantitative analysis to determine, interpolate unknown values and concentrations, protein concentrations in this case. So I will select quantitative analysis and click next. I do have background to subtract from my data, so I'll go ahead and select this first. I know that from my Excel data that the first 2 wells, A1 and B1, are my background wells. So I'll go ahead and mark them as a duplicate with B, mark as background. You have the option to subtract the lowest value, the highest value, or the average of the backgrounds from all your wells using the plate preferences. I'll get into that plate preferences right now, though, shortly. So now that we marked our background, we'll click next. Now we want to define our standard curve. So by looking at our Excel data again, I noticed that A1, the A columns and B columns, those are our standard data. So what I want to do is select our data first within MasterPlex ReaderFit. In this case, I know I'm running in duplicate, so I'd want to select both of these wells at the same time, and then select and mark the sample curve blue. That'll be our first point on the graph. So we could either go selecting each one and highlighting it one group at a time, or you can select the black dot and drag it all the way down to quickly select your wells as your standard group. Now to add values to your standard group, you'd want to select, there's two ways to input your data. So the first way would be to simply copy and paste your independent values. So in this case, I'll go back to my Excel, select copy, go back to the first point, right click, paste data, and select paste independent values. And some of you are probably wondering, well, where'd they go? Where are the independent values? This is a good time to mention that we have multiple views within your data. There are the data displays. So you have your primary data display and your secondary data display. The first display shows the response values on top. And if we toggle between the secondary data display, our lower well grid will show the analyte name. In this case, I haven't added any analyte name, but I did add independent values. So I'll select independent values, and you can see your independent values here. Another way to add your independent values is if you have a serial dilution use the autofill feature. The autofill feature will help you automatically enter your data. So let's select this autofill feature. In this case, there is only one analyte, so you can select all. There's only one standard group, so you can select that first standard group. And our data, our first standard point does begin with 10,000 picograms per milliliter, and the dilution factor in this case is 4. So you select your dilution factor. From here, you can select the dilution direction. So if you have different pipetting techniques for your wells, you can select your dilution direction. In this case, it is straight down, as indicated by the details. I want to select fill and close. And quickly, your standard data has been saved. So we click next. Now we want to define controls. In this case, I don't think that I have a control in this data. However, I can show you how to mark it. Simply, once again, by selecting the well or wells you want as a group or singular, and you can select your control group. If you have values, you could double click into the well and type in your control values for your independent values. If you made a mistake, don't worry, you don't have to copy and paste your data all over again and start from the beginning. You can simply click X. This unmarks all wells and it clears the data for your current marking. It actually won't clear the response value, but it will clear the independent value. So there, marked at X, and it is now clear. Now we're moving on to marking unknowns. And like I mentioned in this quantitative assay, we will be determining unknown values. In the rest of these unknown values are in duplicate. So you could once again select your two wells, select your unknown, green, and mark it as an unknown, and select well by well, or you can select all wells at a time by clicking the black dot and dragging it across your data table. Some of them were empty, so you can just hit OK. Okay, now that we have all of our data set up, we can click next. So we have two options to fit your curve. There is a best fit function. The best fit function is typically allowing the software to automatically choose your parameter. You This feature will automatically select the optimal model equation and weighting algorithm with different parameters to optimize for. You can select these different parameters in the plate preferences. These best fit parameters are root mean square error, R square, or least deviation of percent recovery. While I'm inside the preference plate, you could also change and toggle how many decimal points you want to be displayed. I know some people are working with very small data in terms of values, so you can select as much as up to 10 different decimal points. I like to keep it at 4 just to keep things a little simple. You could also view the the background type, like how I mentioned. You can subtract the background by the average, the peak value, or the lowest value. In this case, we're going to keep it as an average. So, like I mentioned before, you can let the software do the work, or you can do some manipulating on your own in case your kit requires a specific algorithm. In this case, I'm going to go ahead and select best fit. The software, okay, quickly fit our curve, selected 5 parameter logistics with 1 over y weighting. As you can see in the curve, it shows your R square values, your root mean square error value, and a couple different parameters. These parameters A through E can be input into your 5 parameter logistics uh, equation. Within this view, the fit curves is basically where most of the magic happens. You can view different data points for your standard data points within this view. You can select percent recovery. This one is independent values. If you want to have more, you can right click onto the top bar, select the column chooser. You have more data to choose from, more data options to choose from. Let's say response as D if you wanted to see that. If you don't want to see a lot of this information, you can simply grab the column and drag it down and hit X. Within this view, you can see your data points. You can scroll over and you can get information. In this case, well, H1 is your standard group line, your Y values, and your X value. You could also scroll over here and view that D2 and D1. You could also zoom in. The best way to zoom in would be just simply zooming in, scrolling in with your mouse. You can zoom in into the curve, zoom out of the curve. If you have unknown values, in this case we do, you can show that in the display options. So you can select x-axis to have the log scale, or toggle or untoggle it. The y-axis to have log scale, or untoggle it, and to plot your unknown wells. So let's go ahead and plot our wells. And in this data set, you can see that a lot of our data is on the top half of the curve. You can zoom in and even see if any points have been extrapolated. In this case, we do have a couple points that have been extrapolated. You can continue to zoom in and see that there are exactly 2 points, wells G6 and wells G11, that have been extrapolated. Like I mentioned, the curve fitting the fit curves tab allows you to choose which parameter you want to use. So you can untoggle using best fit. And if your kit requires a model equation for a parameter and a specific weighting, you can choose that here. In this case, we'll keep it for selecting for all analytes. There's only one analyte and one standard curve. If we want to use weighting, you can choose that here. If you want to learn more about weighting, we do have a blog. It's titled The Importance of Weighting with 4PL and 5PL. This explains a lot about how the weighting algorithms are used to offset heteroscedasticity and apply a non-constant variance across your data. In this case, we'll leave it off. And you could also fix your lower asymptote to 0. If you did change, make sure you click calculate so that it could recalculate and update your values. There's a warning on the bottom left-hand corner that shows when you need to calculate. Select calculate, and the data has been calculated with a 4-parameter logistics curve. You could also view your points as individual points or average standards. In this case, we have it viewed as an individual point, but if we want to select average standards, your data will look like this. So you will have 1 point with average. So let's go back to individual points. If you're looking for IC50 or EC50 values, in the Fit Curves tab, this is where you can find it, determining those values using the statistics toolbar or toolbox. Please select the statistics toolbox, and a new window would appear. So this is the IC or EC anything, and we really mean that. So you can choose, by default it shows EC50 values and the log of EC50, but you could also toggle between EC50 and IC50, and you can add any EC value. In this case we'll do 20, add, and 80, add. And you can see that information appear in the table. You can quickly print and export this table, or you can select, copy and paste it into an Excel sheet. I'll do that here. Paste. Okay, so let's go ahead and move on to our View Results tab. Our View Results tab is where, you guessed it, you can view your results. You can select different columns. In this case, there are the default sample name, replicate group, response values, calculated values, and mean. You could also select percent recovery, dilution factor, IC50 values by selecting the column you want to see and dropping it into the column. If you don't want to see certain information like replicate group, you can grab your column, drag it down, and it'll be deleted. From here, you could either print your table, you can export to different files, either Excel, CSV, PDF, HTML, or text formats. Also, you can have a report template. There are many people who use this to have a standard report to show, and the template manager is where you'd want to go to set this up. As you can see here, I have several available templates that I've created already. You can first of all create the template you want to see. Select report template and hit save. So you hit save, you can add a name, and a description, and hit OK. And that information will be saved here. The next time you want to load this specific report, simply click report template, select the available template you want, select load, and the table will be showed here. My personal favorite is the one I created back in March of 2011. Select load, and here's your data. Like I mentioned before, from here you could export to file easily. Moving on to creating graphs. Creating graphs is where a lot of customization can happen. You can select your data type that you want to graph. In this case, you could do response values or calculated values. Let's do calculated values. You select wells. You have the chart type to wells, wells by analyte, wells per analyte if you have multiple analytes, and grouping. You also have available to do replicate view. So if you want to average all your replicates, you can see it here. With the replicate view, you have your averaging here. Lastly, if you want to select specific wells to analyze, you can do that here. Let's select all of the unknown wells because those have the calculated values. As you can see, it quickly populates all this information. It's a bit too jumbled for me, so I'm going to go ahead and select just a few points. And then I'll select the replicate view. As you can see, your unknown 4 group has the greatest variance, and this is a great way to determine which unknown values have the greatest variance or the smallest variance. From here, you can do much more customization between bar graph, 3D bar graph, line 3D, the sky's the limit. Go back to bar. And you can also do coloring. I know many people like to stick with the boring black and white, so we did include that option here with ReaderFit. And you also have different chart properties. So you can select different legends, diagrams, axes, point labels. Basically, the sky's the limit when it comes to designing your own graph. And again, you could select print, and you can also save this chart as a template. In this case, I have one group by sample. Like I mentioned in the View Results tab, you could save your template after creating it, naming it and leaving a description, or simply loading an available template. In this case, I'll load this template. Lastly, I want to quickly go over the Customized Report Manager. The Custom Report Manager are reports that our MariBio developers create for the user. This feature allows for the greatest customization of data. So for example, if you wanted to view all your results as expressed in a plate format and possibly highlight wells that are considered to be outliers, you can do this within the custom report template that our MariBio developers will create. If you want to learn more about custom reports, please feel free to reach us at info@maribio.com. So let's go back to the input data tab to make sure that we have added all of our information correctly. So we did do the fit curve. We moved on to the view results, which is here. We even selected a report template. Then we moved on to exporting results. You could either export your results using the View Results tab. As I mentioned, you can export it in any way listed here, or you can create a graph and print it or export it. And therefore you are done after you get this information. Once again, thank you for visiting us here at the maribio.com website. This has been a presentation of MasterPlex ReaderFit. If you have any questions, please feel free to reach us here. If you want to learn more, feel free to reach us at maribio.com, selecting MasterPlex ReaderFit. Support@maribio.com. For sales information, please feel free to reach us at info@maribio.com, or by selecting any one of these hyperlinks for our community, knowledge base, our blogs, and our webinars.